Now, in this video, I'm going to show you how to run to detect multicollinearity in SPSS. Now, one of the assumptions of the classical linear regression model is that their independent variables are not correlated with each other. In other words, there is no collinearity among our independent variables, among the X variables. Now, once the X variables are correlated, or one X variable influences another X variable, this will lead to a problem of multicollinearity in R. So in order to detect whether your model has the problem of multicollinearity, we can use the correlation coefficient to detect if your model have the problem of multicollinearity or has violated the assumption of the problem of independency of the X variables. Now, when I run this particular data set here in R, these are my values. Now you can see that the values are this. Now you can see the relationship between the sales and the engine size of the car is very low, and the relationship between the sales and the fuel efficiency is also very low, which does not actually detect if there is a multicollinearity in the data set. Now if I decide that if I want to do this in R, I said I'm going to run this in R. Now, if I want to run this in R, I go to analysis menu, I go to collinearity, and I check this. Now, the moment I check this, I run this in R. Now, you can see that I have similar values with what I got, the sales and engine size and fuel efficiency. The values are actually low, that does not indicate or shows whether the model has a problem of multicollinearity. That means you can go ahead and run the sales of car on the engine size and the fuel efficiency of the car. Now, but if we decide to add more variables to our data sets, for instance, I decide to add more variables to this data set, I decide to add the size of the car and up to this point into the model, and I run this Pearson correlation coefficients. Now, running this, you can see the sales of the car, running each individual variables. Okay, now we can see when I look at the engine size and the fuel efficiency, you can see that the value is high. Here is horsepower is high, and we can see some of those variables actually have a correlation coefficient of 0.8, 0.7, and above. This can imply that probably there might be a problem of multicollinearity in a data set. But let's really see this, if there is a problem of multicollinearity in my data set. So let's assume we have this data set, and let's go to linear regression. Regression model, we have a linear. Now I have this linear regression model. I want to run sales on all these variables. Okay, now I go to the statistics and ensure that the collinearity, it brings out the linear regression statistics. Now I'm interested in collinearity to diagnose if there is multicollinearity among the variables. Now, when we talk about autocorrelation, we are coming to deal with Dublin-Waxing statistics. This helps you detect if your random error term are correlated with each other. If it violates the assumption of no autocorrelation, that is the Dublin-Waxing statistics that you can see, that is a residual. This deals with correlation between your error term. But now I'm interested in the independent variable x's. Now the assumption is that your x's, your independent variables, should not influence each other. If there is if one independent variable influences the other independent variable, there is bound to be a problem of multicollinearity in your data set. So we want to check that assumption using this model and running all this value on sales and running each of these independent variable to see the sales of car. If the sales of car is being influenced by the vehicle type, the price of the car, the engine size, the horsepower, the wheelbarrow, the width, or the length. Now, so I want to see that, so I decided to run this. Now, once I run this, it gives me all that, but I'm not interested in all this. Where I'm interested, I want to check if there is collinearity in the dataset. First and foremost, I look at the tolerance values. Now you can see the tolerance value very close to zero. A tolerance value close to zero is an indication that there is a multicollinearity in the dataset. Now you can see most of my tolerance value are 0.3, 0.3. The highest is 0.3, which is very, very close to zero. This is an indication that there is a problem or an indication of a problem of multicollinearity in the dataset. And we will look at the variance inflation factors. It can also help to detect if there is a problem of multicollinearity in your model, if your independent variable influences each other. Now, the variance inflation factors of 2 and above is an indication that there is a multicollinearity problem in your dataset. Now, as you can see in my particular model, my variance factors are more than 2. So that says that there is a problem of multicollinearity in the dataset. Now let's look at the collinearity diagnostics. Now looking at all this collinearity diagnosis, we look at the engine values. Now this is collinearity diagnosis. Let's further confirm. And in this particular model, is there a problem of multicollinearity? Now we can use the engine value, also we can use the consumer index to look at it. But looking at the engine value, an engine value closer to 0 is an indication of the problem of collinearity in your dataset. Now you can see most of my engine values from the 4th variable down to 11 variables, the engine values are very, very closer to 0. This to tell you that there is a problem of multicollinearity in your dataset. In other words, your independent variables that are included in your model influences each other, and the result of this is that it's bound to influence or increase your R square. Now your R square explains it shows the variation in your X variable. It shows the variation in your independent variable as a result of the changes or variation in your X variable. So it overestimates your the influence of the independent variable on the dependent variable. And when using this for policy purpose of decision making, you are bound to make error in such decision making. So this is how to detect the problem of multicollinearity in SPSS. You can use the correlation coefficient, you can use the variance inflation factors, and you can use the engine values to also detect it. If you love this video, kindly give it a thumb up. Don't forget to subscribe to our YouTube channel, our Instagram channel, and our TikTok channel. Thank you very much and see you next time.